In this tutorial we will show you how you can collaborate with your team on EMF or Papyrus models in Eclipse based on EGit and EMFCompare. In particular, we will introduce the most basic workflow with a shared Git repository. That means we will use Git merge. In general, the workflow that we will present is of course independent of whether you are collaborating on models or on code, but in the screencasts later on we will show you how this works with Papyrus UML models. Before we show you how this is done in Eclipse, let me briefly go through a couple of slides to illustrate the workflow from a more conceptual point of view. So let's assume we have two developers down here who want to collaborate through a shared Git repository, which is depicted up here. This shared Git repository contains one branch called master, which in turn contains a Git history of 2 commits. To actually start collaborating, in a first step, both developers clone the shared Git repository, and as a result, both developers have the repository on their local machines and can now start to modify the models, the code, or whatever they want to work on. Before the developers actually start committing their changes, it is usually a good practice to create a local branch first. So in this case, developer 1 creates a branch called topic A and developer 2 creates a branch called topic B. The reason behind creating local branches first is as this makes it much easier to isolate the changes from concurrent changes. So once the developers created their local branches, they can start to commit their changes on top of those local branches. So for instance here, this developer puts 2 new commits on top of the branch topic A. However, on this slide we depict branches as if their full commit history is an actual copy of the original branch. So for instance in topic A, we have here the 2 new commits as well as the 2 old commits that originally have been in the branch master. But actually this is not how it works in Git, and let us just spend a couple of minutes on how Git branching actually works, because this will help in understanding the Git operations in more detail. So in Git, branches are actually nothing else than pointers to the last commit of the branch, that is the tip of the branch's commit history. So in this case of the branch master, the second commit is its tip, and this is where the pointer points to. So to create a new branch, all Git has actually to do is to add just another pointer referring to the same commit that we have just created a branch from. So for instance, if we create a new branch from master called topic A, Git will just take the tip of the branch master and puts another pointer called topic A to this commit. Besides that, Git also remembers which branch is the branch that is currently checked out. And in this case we depict the currently checked out branch with a bold font, such as for instance in this case topic A. When we now commit changes to this currently checked out branch, then Git creates a new successor commit of the last commit and moves the pointer of the branch to this new commit as shown here. And of course this same process is repeated for each new commit. With this way of storing branches, Git can determine the commit history of each branch by going backwards from the commit to which the branch pointer currently points to, back to the initial commit of the whole commit history. So for instance, to find out the commit history of the branch master, we take the commit to which the pointer of the master branch points to, this is this one, and collect all commits backwards. So in this case it's just these 2. Of course it works the same way for the branch topic A. So when we go here to the tip of the branch topic A and go backwards, we get all 4 commits. With this way of storing branches, it is actually quite easy to store branches that share a common history without needing any extra disk space, and this also enables to easily perform merge operations, as we will see in the following slides. So let's just continue with the workflow and from now on use the more correct notation of showing branches and commits in here. Okay, so the first developer who has already created new commits in his local branch topic A now wishes to share these commits. Therefore, to make sure his local replication of the master branch is up to date, he first pulls the changes from the shared repository into the local repository. In this case, nothing really happens when pulling all the changes from the shared repository into the local repository, because in the meantime there have been no new commits in the shared repository on the branch master, so the local branch master will remain the same after the pull has been finished. So once the master branch, the local master branch, is now up to date, we can merge the changes that we did on top of topic A into the master branch. So in this case, this is a really easy operation, because Git recognizes that the first commit of the branch that we want to merge, which is topic A, that this first commit is actually a direct successor of the last commit of the branch that we want to merge into, which is this one. So all Git has to do to actually merge those changes into this branch is to move the pointer of the branch master to the last commit of the branch that we want to merge, which is topic A. This is actually called fast forward merge. So once the merge has been done, we have a new version of the master branch locally. So that means that the next step is to push this local master branch to the shared Git repository. So what happens when now the second developer also wants to push her changes to the shared repository? This time there are new commits in the shared repository already. So as before, the first thing to do is to pull the changes from master to make sure that the local master branch is in sync with the master branch in the shared Git repository. So as we can see, the new two commits have now been transferred to the local master branch of developer 2. So in the next step, developer 2 creates a merge of topic B and master, but this time Git cannot apply a fast forward merge. Therefore, instead of just moving the branch pointer forward, Git creates a new snapshot that is the result from a three-way merge and creates a new commit for it. This commit is called merge commit, and it's somewhat special because it's the only type of commit that can actually have two ancestor commits, like this one and this one. So in this case it was quite easy because there haven't been any conflicts, but what actually happens if the three-way merge does not succeed because of conflicts? Well, in this case the conflicts have to be resolved manually, obviously, and this is done by changing the conflicting files, and these files have then to be added in terms of the Git operation called add and committed to complete the merge. Eventually these changes, in order to fix the conflicts, are then part of the commit, of the merge commit that is added at the end. So once we merged successfully topic B into master, also developer 2 is now ready to share her changes. And as before, this is just done by pushing her local master branch to the master branch of the shared Git repository. By this, all other developers, when they pull from master from the shared Git repository in future, they will not only get her change inside this commit, but they will also get her merge commit, and can basically start to work from where developer 2 has stopped working. With this strategy, when you repeat this process over and over again, what you will end up with is basically a commit history such as this. So you will have parallel commits followed by merge commits all over again. So this is what happens when you use git merge. A lot of developers, however, they prefer a flat commit history like this, without parallel commits as you would have here. But to gain such a history of commits, you would have to use rebase instead of merge. However, in this tutorial we will only focus on git merge, and we will show how to rebase your commits in future tutorials. Alright, so here you see my Eclipse installation. I'm using the Collaborative Modeling Edition here. Basically, I've already configured EGit to work with a Git repository, as you can see in the Git repositories view in the left lower side. There is one branch called master, and the last commit has the commit message adds diesel engine. In the project explorer you see one Papyrus project which is inside of this repository, and this Papyrus project contains one class diagram which is shown in the middle, which contains 4 classes. So the first step to do is to pull the latest changes from the shared Git repository. There are of course different ways to do that. I prefer to just right click on the project and select team and pull, and what we see here is that actually nothing happens, because there have been no commits since I last pulled from the shared Git repository, so the update result is nothing to update. Alright, so as a next step we can create a new branch. I like to do that through the Git repositories view by right clicking the branch master, for instance, create a new branch. Then let's just add a title, add electric engine. So in this title you usually put the topic that you want to work on, just to be able to recognize it later on. Make sure that you already also click or enable the checkbox check out new branch, because then you will immediately switch to this newly created branch. As we see here in the Git repositories view, this new branch that we just created has this little check mark on top. That means that it's checked out. Alright, so now we can start to modify the class diagram by, for instance, creating a new class, electric engine. And let's also add a new generalization to it. And now we see that these two files, the notation file and the UML file, are marked as being changed with respect to the currently checked out head version. And in order to actually commit them, you need to go to team commit. And this will bring up the commit dialog, and in this commit dialog you can add a commit message. So let's adds electric engine. And down here you see that there are all the files that will be included with this commit. So basically it automatically selects all the files that have been changed since the last commit. So just make sure you have enabled all of them, click commit. Alright, so once we have committed the work, we can check the commit in the history view. So as we see here, there is one new commit with the commit message we just entered, adds electric engine. And when we go back now, we can switch back to the branch master by double clicking it in the Git repositories view. And we see here the change that we just committed is gone. That's because we switched to the old version in the master. We also see that the commit that we originally added is not here anymore in the history view. And here we can now right click and select merge in order to merge the topic branch that we just created into the master branch. So it's always with the merge dialog, you merge another branch which you can select in this view into the currently checked out branch, which is master in this case. So let's just select the branch that we created with the title adds electric engine to be merged into the master. And now what actually happens is, as we discussed in the slides before, what actually happens is a fast forward merge, since there has been no other commits on top of the branch master so far. So basically the next step to do is to check if the merge actually succeeded, and the easiest is to check that in the history view. So as you can see here, the last commit that we just added in the topic branch, in the add electric engine branch, has now also been merged into the master branch, and you can see that by the green labels next to the commit message. So there is the master branch. It also shows that the master branch is the currently checked out branch because it's in bold font. And this commit is also included in the, of course, in the add electric engine branch. That's the branch to which we added the commit originally. Alright, we also see, of course, in the diagram that the change has been merged. So the electric engine class that we added to the diagram is now also in the master branch version. So once we have merged the commit from the add electric engine branch into the master branch, we can now see that Git or EGit shows us that our master branch locally is now one commit ahead of the remote master branch on the shared Git repository. So what actually needs to be done now is to push this new commit to the shared repository. We do that by right-clicking the master branch in the Git repositories view and select push branch. And in this dialog we can now see to which remote we actually are going to push, and also which branch is going to be pushed. After we hit next, EGit shows us the expected push result. That means which commit will actually be pushed from the local master branch to the remote master branch. In this case, this is the one commit that we created before, adds electric engine. Alright, so we can now hit finish, and then EGit shows us the actual push result, and there is no surprises there, so it's only the one commit that we added before. So we can just confirm this dialog and hit OK. So you also see now that the marker that we had before there, and that we are one commit ahead of the remote master branch, is gone now. And if you want to, it's also now safe to just delete your local branch by right-clicking it and hit delete branch, because we have now merged all commits that were originally on this branch also into the master branch. So there is no information loss if we delete this branch. So, as now developer 1 is finished pushing all his changes to the shared repository, we make now a switch to developer 2. And we can see that we are now in the Eclipse of developer 2, since I named here the Git repository Git2 instead of Git1. Alright, so basically we just repeat the process as before. So the first step to isolate the local changes is to create a new local branch. In this case we name the branch allow for hybrid cars. Alright, finish. This branch is also automatically checked out for us, so we can directly start to make our modifications. In this example we just changed the multiplicity of the association we just marked from 1 as it was originally to 1 to 2. Alright, we can also now, as soon as we save the model, see in the Project Explorer as before that the UML file has been changed. And by right-clicking the project and selecting Team Commit, we can commit the changes to the Allow for Hybrid Cars branch. Let's just enter some commit message here and hit commit. When we now switch to the history view, we can make sure that the history actually shows the new commit that we just created. We see it here, great. So we can go back and check out master again, just as before, since we plan to merge the new branch into master. We can also see here now that the multiplicity has been changed back to 1. In the other branch it was 1 to 2. And we can double check in the history that the commit that we just created is not there anymore. So as we see here, this is just the initial commit that has been there for since the beginning. Alright, so in the next step we can now merge the changes from the new branch into the master branch. But before we actually do that, we should first pull the changes from the repository. So we click the Git repository and select pull. And as before, we see the fetch result. That means fetch is basically just fetching all the data from the shared repository to the local repository without merging it yet. So from this fetch result we see that there is one remote commit that we haven't merged into our local master branch yet. This is the commit that the other developer already created. And we will see that this is a fast forward, that this seems to be a fast forward merge. So as soon as we hit OK and double check in the history, we see that the remote change has been merged into our local master branch as well. So when we now go back, we are now ready to actually merge the allow for hybrid cars branch into the master branch. So we just select the branch to be merged into master in the merge dialog and hit merge. And what we see here is that the merge result is not as before a fast forward merge, because there has been a remote change in the remote repository. But nevertheless, the result is merged. That means there hasn't been any conflicts and the merge actually succeeded. So when we double check the history now, what we actually see is we see the initial commit that has been there before both developer 1 and developer 2 started to work. Then we see the remote commit of developer 1 that he actually already pushed to the shared repository. Next to it, above it, we see our commit that developer 2 just did. And as discussed in the slides before, we see the merge commit that has been automatically created for us. So we also see now when we go back to the diagram that actually the effects of the changes have been successfully merged. So we have the electric engine that has been added by developer 1. And we also have the change that we just did before by changing the multiplicity from 1 to 1 to 2. What we also see is in the Project Explorer that we are now 2 commits ahead of the remote master branch. That means so that's basically the commit we just did before and the automatic merge commit that Git created for us. So in the next step, what we need to do is to push these 2 commits to the remote repository. We do that as before, so we hit push, we make sure that the remote is correctly set and that we are pushing to the master branch. And now when we hit next, we get again the expected push result, which contains the 2 commits that we now, the one that we created and the one that has been automatically created for us. So when we hit finish, what actually happens now is that the remote remaster branch is updated and contains the new commits that we created locally. So now we have done basically one round trip for the full workflow. But in this case, we were lucky, there were no conflicts at all. So let me just show you how the same process works when conflicts actually occur when you merge your topic branch into the master. Therefore, I will switch again to developer 1 and I will do some conflicting changes and try to merge them. So back in the Eclipse of developer 1, we can see that because the Git repository is again named Git 1 instead of Git 2, What we now can make sure that the state of this repository is basically as we left it before. So we only have this additional commit that developer 1 created. We have not pulled the changes yet. So we directly start off by just creating a new branch to isolate the effects of the new changes that we are going to make. So let's call this branch change multiplicity. So basically the idea is to, in this branch, create a change of the same multiplicity as developer 2 change, just to provoke a conflict. So we just select the association, go down there to multiplicity, and instead of 1 to 2 as a multiplicity, we select 1 to unbound. So let's save that. Now we just, as before, take the changes and commit them. Let's just enter a commit message here. Change this multiplicity so that a car can have multiple engines. And hit commit. Alright. Now we switch back to the master branch because we plan to merge those conflicting changes into the master branch. But of course, to actually make them conflicting, we first need to pull the changes from the remote side. That means we hit pull, and as we can see here, the result of this pull is basically the addition of 2 new commits, and that's the commit developer 2 created. So that's the one is the change from the association of 1 from 1 to 1 to 2, and the other one is the merge commit, as we see here. So let's now hit OK. We also see that in our currently checked out master branch that the association multiplicity is now 1 to 2. So that's our local version now. And we of course also see the electric engine that we added before. So now we want to merge the changes, the conflicting changes we did before, into the master branch. So we select the change multiplicity branch to be merged into master. And what actually happens now is that Git tells us that the merge result is a conflict. So what we actually need to do is now to resolve it manually because the merge stopped and needs us to do some resolution. You also see here that the UML file is actually marked as being conflicting with this red icon, as well as you see here the state of the Git repository is currently in the conflicts state. To actually resolve the conflicts, we need to, the easiest way is to use the merge tool. So we just go to team and select the merge tool. And what you actually see here is EMFCompare, which shows you all conflicting changes as well as all the left changes and the right changes. But all we actually need to do is to resolve the conflicts here. So we see there are 2 changes which are in conflict, the one change of the multiplicity to 2 and the other change of the multiplicity to unbound. So we just need to basically select one of those and accept or reject the changes. So as we can now see, the change has been automatically resolved. Let's save that. Besides the changes that we resolved, we of course also get a list of all the other changes that we can investigate, but for now they are not very interesting. What is very important is to see that we have now accepted the change of the upper bound of the multiplicity to unbound, and this is also reflected in the local version now that we have here now in the master branch. So to also tell Git that we actually now resolved the conflict, we need to add the changed UML file to the index, because when you are in a conflicting repository state, you cannot directly commit that. So you would need to select add to index. I can show you what happens when you still want to commit. There's nothing bad, but it's just an error message that you get that you cannot commit now because your repository is in a conflict state. Alright, so let's reselect UML and add the resolved UML model to the index. So what happened now is that we told Git that we resolved the conflict, and so the state of the repository changed from conflicting to merged. And in order to actually complete the merge, we need to commit those changes. So here you see that the logical model support of EMFCompare kicks in. So although we just selected model.uml, it basically tells us that within the merge operation or the commit operation we should also include model notation file. It's always a good idea to just confirm that. And here we have the opportunity now in the commit dialog to modify the commit message. So each merge commit, irrespectively of whether it is a conflicting merge or a succeeded merge, an automatic merge, there is this commit message showing that which branch has actually been merged. If it is in addition a conflicting merge commit, we have also this text here that indicates which files have been actually conflicting, and we have the opportunity before we actually commit the changes to add additional information such as how we resolve the conflicts and stuff like that. So let's just confirm that here and hit commit. And what we see now is that the merge is actually succeeded. So let's double check the state in the history view. So what we see here is basically this is the commit both developer 1 and developer 2 started off, and this is and we see here this is the merge where developer 2 merged the changes with developer 1. And this is the commit where we started off from to create the conflicting change. And this is the actual commit that contained the conflicting change. And in the end we see the commit, that the merge commit, that not only merges the parallel commits, but also it resolves the conflicts that we had in the UML model. So that's basically it, what I wanted to show for today. So we saw the full workflow with parallel commits on the remote repository that have been easy to merge with commits that have been in conflict. So if you have any further questions, then just add comments or contact us directly, and see you soon. Take care. Thanks a lot for watching.